Hello, good afternoon. This is Swapna, Mathematics faculty from EDUHUNT IIT and NEET Academy. So today we are going to start a new chapter which is set theory, right? So what will be there in the set theory? Children, please tell me what will be there in the set theory. The name itself, the title itself tells you like set theory means you will discuss about theories about sets, right? In general, you will discuss theories about sets. But actually, what are sets? So, before learning about set theory, starting from the title, you should learn what do you mean by the set. Correct? So, if you are aware of definition of set, you can derive a lot of theories about set and you can learn terminologies about sets which we are using to get in set theory chapter. Okay, chalo. So, here we will begin set theory with a definition of set. So, what do you mean by a set? Right? For suppose girls will be aware of this sets because they will be wearing it as an appearance, they will be wearing it as an ornament, right? So, set is usually you will be aware in that field. So, similarly, I'll take the same word set. Set is defined as well-defined collection of objects. So, what is a set? It is nothing but, just a minute, set is nothing but, a set is a well-defined collection of objects. So, if you take the set, you will be nothing, all beads are collected and it is joined so that you call it as a set. Correct? Similarly, in mathematically, how do you represent set? A set is nothing but well-defined collection of objects. Collection of objects, all objects which will collect of same type is nothing but set. Is nothing but set. Understood about the definition of set? I told you like it should be well-defined. So, you have that specific notation regarding well-defined. What is it? Well-defined means, for example, let me take one example like a group of sincere people which I was given in the statement. A group of sincere people. That is also a group. You'll have some people. Which people it is? Sincere. I'll highlight this word called sincere. A group or a collection of sincere people. Can I say this is a set? Anocha ninadi set ani? Madam, mere kada chepparu. Just now you told that a group or collection of any objects is defined as set. Of course. But I told you it is a group of objects but that should be well defined. Well defined. What do you mean by it? Ante enti? So, if I used a word called sincere. This is not well defined. This is not well defined. How I can say that? For suppose some Ram and Sita. There are two people. Okay? In my point of view, Sita is very sincere girl in submitting her homework. Mine is math subject. Okay? Maybe she is very good in submitting math subject homeworks. But in other subjects, for suppose there is science, physics. In physics, she may be a weaker student so that she cannot submit her work. So, according to science subject, science teacher, this girl is very much less or not sincere. Correct? So, this is a generalized example. So, according to my point of view, Sita is a very good girl and she will be submitting all her works on time. But the same girl, she may not be sincere in the science subject. That means sincere is not well defined. It is not standard. Okay, it is not standard. So, that is why That is why these type of terminologies, even though if you consider a group of sincere people, that may differs according to the opinion of the people, right? So we cannot say in that cases these are well defined objects. Did you understand? So can I say this is a set right now? No. Did you understand, child? So this is not a set, because as per the definition of set, it should be a collection of well-defined objects. Well-defined objects, correct? Yes or no? Yeah. Similarly, take another example. A group of learned boys. A group of learned boys. Learned is again, it is not a specific or well-defined word. So this is also not a set. This is also not a set. This is not forming a set. Even though, why I am telling you all this? If you see the word like group, correction, collection, okay, in the statements, you need not be tick simply this is a set, ma'am. No. ఒక సెంటెన్స్ లో గ్రూప్ ఆర్ కలెక్షన్ చూసినంత మాత్రాన అది సెట్ అవ్వదు. సెట్ అవ్వాలి అంటే వాట్ ఈస్ ద మెయిన్ ప్రయారిటీ? It should form a well-defined collection of objects. That is a definition of set. Now, ma'am, if these are not an example of sets, what will be the example of set? మరి దేన్ని మనం సెట్ అనొచ్చు? దేన్ని సెట్ అని అనొచ్చు? Set, for example, I will tell you the generalized example. There are 8 planets in the solar system. నన్ను అడిగినా నేను 8 ప్లానెట్స్ అనే చెప్తాను, మిమ్మల్ని అడిగినా 8 ప్లానెట్స్ అనే చెప్తారు. మిమ్మల్ని అడిగితే మీరేం 7 అని చెప్పరు కదా, 6 అని చెప్పరు కదా. Everybody will have the same planet system. That is a set, right? A set of natural numbers. If I give an example in mathematical terminology, a set of natural numbers, a set of natural numbers. So that will not change with respect to aspect of different people opinions. Yes. So what are the example of sets? A set of natural numbers, a set of real numbers, a set of integers, right? A set of irrational numbers. You can learn many things. So I hope you people got clarified what is a difference between set and what is an example of not set. Understood, child? So again I repeat, set is nothing but a well-defined collection of objects, which is set. Understood? So shall I get back to next one? Okay. Chalo. So my next. The next topic you are going to learn about notation of set. How you will represent, how you will denote the set in mathematics. Okay? Fine. For example, a set of rivers. Let me take a normal example. Set of rivers. So, if I ask you a set of rivers, you will be telling like Ganga, Yamuna, Saraswati, Narmada, Tapana, etc. Right? You will tell a lot of rivers which are there in India and out of India. Right? Yeah. But, and if I will write all the examples, but how you will notate the set? Right? So, a set of rivers every time being represented in longer format, that takes a lot of time and it will be clumsy too. The notation of set can be notated with a, how will be notated, are usually notated with a capital letters like capital A or capital B or capital C and so on, anything extra. Any set can be represented with a capital letter. Clear? So, as this is a reverse, I will notate with how I am writing set C. I will represent this set as R is equal to. In this set, so what are rivers here? Narmada, Yamuna, Tapati, all these are rivers only, right? So, all the rivers, like I will write here Narmada, next Yamuna, so on. We have many rivers like that. Yes. So, these examples of set are called elements of set. So, second terminology I am using here. All the examples, whatever you are expressing in the given set are called elements of set. So, these elements are usually represented by small letters. Set will be represented by the capital letters, and the elements of a set within the set are represented by the small letters. Clear up to now? Yes, Amma? Anybody is having doubt up to this extent? Correct. Okay. So how I am expressing now? R is equal to N. I should be represented with small n, Y, T, so on. So, these are representing elements. N, Y, T are elements of the given set capital R. I hope I am clear up to this extent. Can I get back to next point? Yeah. So, if an element P, for suppose you want to express like some element is belonging to the set. So, what is the notation? So, this Narmada river is belonging to set of rivers R. So, how you will be expressed it? What is the notation of this? See, N, Narmada. N represents Narmada, belongs to which set? R. So, N belongs to R. This is the expression. N belongs to R. Small n belongs to R. This is the symbol which is known as epsilon. Right? So, if whenever you see this notation, that particular n is an element, right? This is an element belong to set capital R. Understood? You able to visualize it? Yes. So, up to this extent, I have told you about definition of set. Set is nothing but a well-defined collection of same objects. Correct? So, that is a definition of set. Second one, I told you one example of set. Right? Example of set. That means you can give an example of set of natural numbers, set of real numbers, set of whole numbers, anything is fine, right? Next, I also told you the examples of not becoming a set, right? So, if you see anything which is not well defined in the statement, that will be not considered as set. I told you learnt, sincere, right, good. So, we cannot consider these are examples of sets. So, this was my third one. Next, I told you about notation of set. So, how I can notate? Notation, all sets are represented with capital letters like A, B, capital C, D and so on. And the examples of set, whatever you are writing within the braces, those are called exactly correct, which are called elements of set. Yes or no? Yes. Elements of set. So, all elements are usually represented by small letters. That also I told you in the slide. Yes or no? And if one particular element, I told you, if any element belonging to the set, then how you will be represented? This is the representation of any element belonging to the set. That will be my third point. And you may get a doubt, ma'am, if any element is not belonging to the set, for suppose, then how you will be representing? For suppose, Kerala. Kerala is a state, but it is not a river. So, Kerala does not belongs to R. Does not belongs to R. So, this is how you will represent. Here it is does not belongs to, here it is belongs to. So, that was my D and E points. Clear with the slide? Please have a glance of it so that we'll be getting back to the next one. Okay, chalo. So, we will move to the next part of set theory. So, what is this? Representation of set. So, how you will basically represent the set? Sets can be represented by two different forms. Set will be represented in the two different forms. One is set builder form or rule form. Second one is roster form. So, we can represent sets in how many ways? Two ways. Okay. So, we will express that in detail. Let's get back to the slide. Representation of set. So, first one I told you as usual, this is roster form. That is roster form. Okay. It is a method which represents set by putting a list of objects within the braces by collaborating all the elements of the property which is going to exhibit, that will keep it in the braces. Simple ga cheppali ante oka set మీ దగ్గర ఉంటుంది కదా, దాని నుంచి ఎలిమెంట్స్ ఏవైతే రాస్తున్నారో, putting all the elements and representing within the curl braces. This is nothing but curl braces. That is nothing but roster form. Let me discuss one example so that you will have clarity. Okay? Chalo. Let A be the set of natural numbers. So, this is a normal statement, right? Set of natural numbers. So, if I say like set of natural numbers, what you will be doing? Immediately you will writing down like 1, 2, 3, 4 and so on, right? So, that is nothing but A is a set. I told you that will be represented with capital letter. You should be getting habituated how to represent set. Okay? Capital letter A is equal to what are the elements of A? 1, 2, 3, 4, 5 and so on. And so on. So, all the elements I put it within the braces. See? These are the curl braces. This type of form is called roster form. Roster form. This type of form is called roster form. Okay. So, we will have another example. B. Let me take another set, capital B. Here I have taken the words, the letters like B-E-S-T of the word best. So, here also I put it all the letters of the word best within the curl braces. So, this is nothing but roster form. So, whatever the elements of set are there, that you need to represent in the curl braces, right? Then in that case, we can see it is in the roster form. Clear up to this? So, we have other type of representing a set which is rule method, or it is also called as set builder form. It is also called as set builder form. So, what is the set builder form? Which is quite opposite to the roster form, I can say. This time, we have all the elements of given set and we need to prepare and we need to create one statement which satisfy the condition of all the elements whatever we have. Did you understand what I am saying here? Yeah. So, this is also a method of representing a set. That is what I just told you now. By writing the property satisfied by the elements of a given set. Okay. For example, let me take one example and narrate to you. Okay. Fine. So, here we have an example A, set A. This is nothing but set of whole numbers. By looking at this example, you can say within the fraction of seconds, correct? Am I right? Because it starts with 0. So if I want to write a set builder form, I need to prepare one statement which satisfies these given elements, correct? So I can say like X, this can be X, right? So X is an element which satisfies all the properties of P. What do you mean by like? So X, how I need to frame of this? So for example, how I need to write X such that you are taking such type of element which is belong to W represents whole number, correct? But at the same time, whole numbers in the sense you will have up to infinite. But I am not writing all whole numbers in this particular example. So, the numbers I am writing, the whole numbers I am writing which are less than 7, correct? So, I am taking such type of whole number which is X belongs to W and at the same time X must be less than 7. So, these both conditions it has to satisfy in order to become it is an element. So, this is nothing but whatever I told, this is nothing but set builder form. Set builder form, or you can call it as an other way, you can call it as like rule form, rule method or rule form, anything is fine. Understood? Am I clear up to this? Can I get back to next one? Chalo. So, you have learned even representation of sets. Now you are going to learn about types of sets. What are different types of sets will be there? That will be my next topic. How many types of sets does exist? Right? So, first one. First is like finite set. First is like finite set. Second one is infinite set. Third one is equal sets. So, before going to learn about these type of sets in detail, I'll just give glance of this. Okay. Starting with finite set, the name itself clearly tells you like the number of elements, right? The number of elements in the set, the number of elements in the set are finite. The number of elements in the set are finite. I told you. Means you can able to count, you can able to predict the last element of a given set. That was actual meaning of finite set. Example if you want to give. Yes, very good. Somebody is telling me here out. Yes, 1, 2, 3, 4, 5. Of course, here you can able to predict how many number of elements are there in the given set. Yes, in the finite set, this was my first point, and the second point, in the finite set, you can able to say the first and last element, identifying, you can able to identify first and last element in the finite set, correct? Next, infinite. In the infinite one, number of elements are not able to count, not able to count. So, we can say like what is the first element, but we cannot say what is the last element, right? Okay. Equal sets. This is quite different one. Equal sets. What are equal sets. Let me take, we'll see what are equal sets in the next slides. So first one is finite. Just now I told you a set in which the process of counting of its elements and surely comes to an end. That is what I told you just now, right? You can able to predict the first and last elements of a given set. Yes or no? Yeah. So example, let us take one set capital A, and what are the elements? I have represented like B, C, D. How many number of elements are there? That is not a problem, but I can see a last element, that means it is a finite set. Next, let me take another example, B and C. Next, set of all volcanoes in the world. So these are like finite sets of examples. Let me explain about infinite set. So what is an infinite set? I told you, in which the process of counting of its elements does not come to an end. So you cannot able to predict what is the last element of a given set. You cannot able to see, you cannot able to find what is the last element, right? So infinite, it will keeps on going. Similarly, example, I am not having last element over here, so that is infinite set, correct? We can give n number of infinite sets. So next is like equal sets, right? So what do you mean by an equal sets? What do you mean by an equal sets? What do you mean by an equal sets? Equal sets are such type of sets. Consider an example A, set A is equal to, let me take set of vowels, okay? What is set of vowels? A, comma, E, comma, I, comma, O, comma, U, right? And B is also set of vowels, but this time I have just I have just rearranged the elements like E, I, A, O, U. Both are representing set of vowels only, right? In A, you have same number of elements, right? In A, you have same number of elements. In B also, you have same number of elements, right? So that means then what are the elements which are existing in set A and B? That must be equal. That must be equal. So then you can define that is a equal set. So let me give another example. A is equal to 1, 2, 3. And if I write B is equal to 3, 2, 1. The elements which are existing in A and B set are exactly equal and same. So that means it is an equal sets. Understood? Whatever the elements you are putting in the, you are collaborating in the, within the braces, that must be equal. Then in that case, you can consider it as an equal sets. Clear? Understood? Can I get back to the next one? Infinite set is done, equal set is done. Next one, you are going to learn about empty set. The next type of set you are going to learn about empty set. What do you mean by an empty set? This will be your doubt. Empty set antene em undadu kada. Empty ante enti? Null. Em undadu, will have nothing. Empty is nothing but nothing element will have. Ante em lekapovam set antara? Em lekapovam ante? We'll just watch a definition of empty set. I'll come up with you. Okay. A set having no element in it is called as a empty set. Of course, if you do not found any element common, right? If you do not have any element existing in it, then you call it as a empty set or null set. How you will represent? It is represented with pi. So that is called pi. Empty sets are represented with pi. So pi is equal to, you don't have any elements within the braces. See, within the curl braces, you don't have anything. So this is representing empty or null set. So let me have an example for it. Okay. Okay. So for example, let me take x belongings to natural number. You are taking one type of x. So what are an examples of natural number? If you want to write elements, you will start writing from 1, 2, 3 and so on. Correct? This is a set of natural numbers. This is a set of natural numbers. Correct? And at this is, let me take, this is one thing, and let me take both, you are taking in a same set, you should not forget that. X is an even natural number less than 1. What are even natural number? Even numbers are those numbers which are multiple of 2. Correct? Even natural numbers means it starts with 2 and it is less than 1. Can you found any such type of even natural number which are less than 1? No, right? No. Even natural numbers are actually starting from 2. Right? Even natural numbers 2, 4, 6, 8, right? If you want to express like, you'll write like 2, 4, 6, 8. Which are less than 1 means you don't found any such type of even natural number. So, in that case, we don't have any common element between these two. That means we'll have empty. Empty. Did you understand in which case you'll found empty sets? If you don't have found any common element between two different sets, then you can say it is like empty set. It should satisfy the given property first of all. The elements whatever you are putting in the curl braces, it should satisfy the given property. But it is not. Yes or no? So, x is a natural number. Of course, we do have elements for individual sets if you write it individually. But if I comprise both the statements together, we don't found any common element. In that cases, we'll represent it. If you don't found any common element, if you don't found any existing element, then you call it as a null set or empty set. Clear up to this? Chalo, we'll get back to next one. Next one is singleton set. Single. What is the next type of set you are going to learn here? Singleton set. Single means you'll found only one common element, right? Single, you will have at most one, not more than one. If you have only one common element, then you can call it as a single set. What is the example I have taken out here? X is a natural number and x is less than 2. Natural numbers means basically you will start from writing 1, 2, 3 and so on. X is less than 2 means you will have many things like 1 is the last number, 0, minus and so on. So, but you can find a common element 1 over here. Correct? X natural number అవుతూ x 2 కన్నా చిన్నది అవ్వాలి. అలాంటి 2 కేసెస్ ని సాటిస్ఫై చేసే ఒక ఎలిమెంట్ ఏమన్నా సాటిస్ఫై చేస్తుందా అంటే yes we do exist, that is 1 over here. We can found only single element. In that case we can conclude those are singleton sets. What type of sets are those? Those are singleton sets. Done. Next one. X belongs to an and I am telling you other example. 2x is equals to 8. So 2x is equals to 8. What is the value of x from here? X is equal to 8 divided by 2, which is 4. Right? 2 ones, 2 fourths. So x is 4 and x is belong to natural number. What is that property? What is that element which is getting satisfied here? 4, and that is the only single element. We don't found any other solutions for 2x is equal to 8 over here, right? So that is nothing but x is equal to 4. So that is also an example of singleton set. Correct? Yes. Can you please give me other example? Now you just tell me whether this is an example of singleton set or not. Okay? Is this an example of singleton set? Please tell me. Is this an example of singleton set? Very good. This is not an example of singleton set. Why? X belonging to natural numbers, you'll start writing from 1 to 3 and so on. But whereas in this operation, x minus 1 equal to 0, that means x is equal to 1, and x minus 2 is equal to 0, x is equal to 2. So we do have two different values. So, and hence that is not an example of singleton set. That is not an example of singleton set. Am I clear up to this? Huh? Can I get back to next slide? So, yeah, I have told you about equal sets. So, equal sets, what we have discussed regarding equal sets, if two sets containing same number of elements, then you can call it as an equal sets, right? For example, A is equal to 1, 3, 5. B is also equal to, what is the B actual set they have given? X belongs to natural number and X is an odd number less than 7. What are odd numbers? 1, 3, 5, correct? So, in that case, both are having same elements. So, this is representing an equal sets, correct? So, this is a concept 1 of set theory. So, just I want to recall you what we have learned in the concept 1. I have started the session by defining a set, and then we have expressed the notation of sets, and we discussed about elements of set and their notation and examples of set and not being a set, correct? And we have talked about types of sets, in which the first one is finite set, second one is infinite, third one is singleton, equal sets, empty sets. So, we learned even this type of sets. I hope everybody has got clear. In the next session, we are going to discuss about worksheet number 1. Meanwhile, you also solve the problems. And then if you have any doubts, we'll get back and discuss in our next upcoming videos. Stay tuned. Thank you. Bye-bye.